Aloha, Rich Halverson here. This is ITS128, and in this video I'm going to cover Chapter 9, where to find what you need to do to learn Chapter 9. Let me get myself out of the way. All right, so you see Chapter 9 is it looks like it's a pretty big chapter. The concept of a function is not that difficult. So what I'm going to do is I'm going to refer you to a set of videos that the other instructor, the other ITS128 instructor, recorded. And so if we go back to the syllabus page, go down to click on video lab video archive. Am I in student mode? Yes, I am as a student. And I added another link here. The other ITS128 instructor here. So if you click on this, let me see if I can open this in a new link. Okay, these are his videos. Back then, Zybooks lets you rearrange chapters and split chapters, and I have done that for the semester that we're in right now. But the functions chapter is the same. So that semester it was chapter 6. Okay, so you can start watching his videos here at chapter 6. The sections are named the same all the way up through 6.20, and that would correspond to 9.17. I think I might have removed some sections, okay, which is why his sections go higher. But he's very clear, and the thing though is that he doesn't really go over any challenges. He leaves those for you, and he doesn't go over any labs. So that's what I'm going to do.
Aloha and welcome. In this lesson, we're going to be talking about user-defined function basics. So what are functions? Functions are...
All right, so that's that. So you can go watch those videos to learn these sections. Now, for these two labs here, you need to know how to do the exact change thing code, and there was another exact change lab earlier, and I believe it was in chapter 5. Okay, so if you go to chapter 5 and you see there's an exact change here, actually I think what happened was I don't think the video for chapter 5 covers that, because I think I cut it short. But you can go to, if you go back here and click on the spreadsheet of previous semester lab videos, click that. You can see that over here, these are outdated. This is outdated. I more or less purposely don't keep this up to date because you know, you really should try to do these on your own. But if you really have problems and you search enough and have the persistence can get you an A. So here we have the exact change video, and here's we have both exact change and leap year video, which is what the two are here. Wait a minute. Yeah, right. 9. Exact change and leap year. Okay, I can't remember which one. I think maybe exact change is covered, but it's the leap year one that's not. That there was not a video. Ah, yeah, right. I remember. Actually, I'm not sure. You can check. Anyway, in either case, we have these two videos from long ago that go over the actual code to find the answers. And once you have code to find the answers, it's real easy to turn it into a function, you just put the function declaration above it and then indent everything, and then you have a function. So so that's where you can find lectures and how to do the labs for chapter 9, for our chapter 9. Let me close these up. All right, so what's left is these challenge activities. So let's do some challenge activities, and let's get started here. Here, this goes through a simple explanation of functions. John Johnson's videos are very good here. You know, you got some code here that you seem to be repeating all the time. And instead of repeating the code all the time, why not just make a function that has that code once? And you have a parameter, and that parameter variable is referred to or referenced inside the function. And then you return a value. So then when you use this F2C function, you just do it this way, where you call the function with the parameter. On the calling side, it's called the argument. And so this, with this function and this main program, it accomplishes the same thing as this main program over here, which has this code repeated 3 times. And you see the idea here is, you notice here, oh, you know, the person typed it in. This time the person typed in a mistake. See, a plus sign instead of a minus sign. And that's where a function, once you get the function right, then you don't really have, then you don't run the risk of, you know, typing the wrong thing in next time. So let's go down here. This makes sure you understand this. Let's quickly go through this. This is how calling a function works. Okay, so we have this is a program which prints out the words say cheese, and then it calls this function called getFace, and it's when this function is called that this getFace executes, and it comes down here and it defines a variable called this, and it contains this string of characters, and then this thing will return that string of characters. So in place of the function goes the string of characters, goes what is returned. So what's going to be printed is what is returned from this function, which is going to be this thing. So if we step through this, we see the first thing was just to, it's sort of it stores this information. It doesn't execute it, just store it. Doesn't even do any syntax checking, just executes it. And then so this is just stored, and then now this statement is executed. So let's execute that. See, and then prints out say cheese, and then it goes down to execute this statement. And what that does is that calls the function. So now we go up here and we're going to execute the function. So next is this statement will be executed, and then next the return statement will be executed. So this right here is replaced with what the return value is, and then when we execute it, oh, here this is just the return mechanism, and then this executes, and here this is what was printed out. And you see that's what this is here. It's an O space O, and then a new line, space O, and then a new line, and then O. See, so that's what it prints. And now we're going to print this last thing there. And so did it turn out okay? Okay, and then we're done. That's 8 steps. So that's basically the idea of a function. So this is a simple challenge activity right here. We can just do call pattern twice in print statements to return 10 characters. So we can just do print get pattern, and then print get pattern. And I think that's all we need to do. Okay, so the output's going to look like that. So the first time we're just returning this in place of this. So that's what prints. And then we're going to call it again, and it's going to return this in place of this, and that's what it prints. Okay, so when we run it, we see that it prints like that. So that's how it's supposed to look. All right. And here, this just now formally defines what a return statement is. And so that's what we've been doing up here. We're using this return statement. A function may not return anything, and we don't see any examples of that yet, but we will. Okay. So all these examples so far have actually returned values that replace where the function was called. Okay, so this goes over that again. So here, and the return statement can be as fancy as you want. This is just an expression. So oftentimes you would do the calculations beforehand and then just return a variable value. Or you can actually jam it all, if you can, jam it all into the return statement itself. That's kind of what this does. All right, so in this particular example here, there's a argument of 7, and when this is called, when this function is called, which is what happens right here, then the 7 is going to be what this, what the value of this variable is. And so this is going to be 7 times 7, and it's going to return what 7 times 7 is, which is 49. And so in place of this thing here is 49. You get what I'm trying to get. 49. And so now num squared equals 49. And so it prints out as 7 squared is, and then the 49. So anyway, you can click on, make sure you click on that so you get the points. So this reinforces that. Kind of defines parameter is the function input. So when you're defining the function, you call that thing a parameter. When you're calling the function, you call that thing an argument. All right. So this talks about parameters and arguments. Here we have a function that takes in a parameter. It takes that parameter, divides it by 2, and it defines this variable here, pizza radius, as that. And then it defines a pizza area as this math.pi means we're going to use the pi function in the math module. Okay, so math.pi is the value of pi, which is 3.14159, so on, and then multiplied by the pizza radius here, which was calculated here twice. So this figures out what the pizza area is from the diameter. So we return that value, and so in this print statement here, we're saying we want to print out the area of a 12-inch pizza. So we're going to use the calc pizza area function, which we define here, with an argument of 12. And so it goes through this calculation, 12, and it's going to return whatever the value is for pizza area. And that's what's going to output right in this place right here. So if we click through the steps, we see this does, you see this down here, it goes through, and here it's actually calculating pizza, and then it returns it, and then it outputs, this is the one for 12. And then next it's going to do the one for 16 inches. Anyway, so let's go down and see if there's any more challenges. Okay, here's 3 sets of challenges. Okay, basic function call. Complete the function definition to return hours given minutes. So so the minutes is the argument or the parameter, and hours is going to be the return value calculation. So if the input is this, it's going to return this. So we have this, we read in minutes from the user, it's a floating point number, and then we call this function with an argument of whatever we read in, and it's going to return, I can just do return orig, copy, paste, orig times 60, right? Wait, divided by 60. Divided by 60. So if we input 2010, it's going to come out with this answer. And there's a decimal point there, so we're going to do the floating point divide. Let's see if this is right. Okay, very good. It is right. Okay, what's this one? Enter the output of the return value. Okay, so the argument is 2. So we go up here and we execute this function with the parameter of 2. And so it returns 2 plus 1, which is 3. So it returns, so in this case, it's going to return a 3. So this gets replaced with 3. And that's what prints out, 3. And we do the return because it's a print statement. Okay, very good. The next one is going to be, we take in 2 arguments, 2 parameters, x and y, and we add the 2 together, and that's the value that we return. So this is going to be replaced with 6. 4 plus 2 is 6, and so it's going to print 6. So you put that in there. What's this one? Here it's the same thing, except for we calculate it first, and then that's what we return. This is actually better. I like this better. You know, I like to see all the calculations up here, and then the return is just the value, the result of the calculation. So anyway, you can do those. All right, what's this one? We're going to define a function called calcval that has 1 parameter and returns whatever that parameter is minus 5. So let's do a function here called function calcval colon, and it's going to be oh, there's a parameter p. I'm going to just use p for parameter, and I'm going to say return p minus 5, just like that. Uh-oh, I spelled something wrong. Oh, what did I do wrong? Well, I got the wrong language. In Python, it's def, not function. What language is function? I believe JavaScript is function. Anyway, so this is def. Define function, this. Let's see if that's right. Yeah, that's right. Okay. The next one would be returns the sum of the 2 parameters minus 10. So here we would do something like def calculate val, copy, paste, 2 parameters, p1, p2, you can name them anything you want, x, y, whatever, And we are going to return, so I'm going to say P3 equals P1 plus P2. 2 parameter returns a sum minus 10, minus 10. And then I'm going to return P3. See if that's right. Yes, it is. So you have flexibility here on how you describe, your code and the variables that you use, and that all turns into your personal preference of things. All right, very good. Print functions. Okay, so here, this is just, it's common to have functions to print out stuff, especially when you're writing code for large programs, because you want to print out intermediate values to see if your logic is correct. But the other point with this is it's a function that doesn't return any values. Okay, if a function doesn't return any values, then that means the function does something else. It does some calculations, but it's either just prints. In this case, print functions just take data in and print it out on the display, but doesn't return any values to the program. So then those functions can just sit all by themselves, and they don't have to be on the right side of an assignment statement. It doesn't have to be something equals the function. It just the function. And so here's an example. We have a function here that just prints out these things. It takes in this items and price, and it prints out the order ID, and then it prints out the number of items, and it prints out the price, and that's all it does. See, so when you use the function, you don't have to say something equals the function. You just put the name of the function there and put the arguments, and then go. And these are called void functions because they don't return anything. A function with no return statement is called a void function. And so if it does return, if you do have it over there, it's going to return a value of none. Okay, so if you should happen to put it on the right side of an assignment statement, that's the value is going to be none. So that could screw up your calculation or not. Okay, so so here's an example of a function that in the regular program we wanted to print out the greatest on earth, and then we wanted to print out the greatest song on earth. Okay, and of course the function way to do it is you have a function which takes in the word as a parameter and then prints out the greatest and then whatever the word is and then on earth. Okay, so and then you just call the function on a line all by itself with the argument, which is the word that you want to print as the greatest show, the greatest thing on earth. And so that's how that works. So this is a use of a function where you write the code for that part just once, and then you use it as many times as you want to. That as opposed to writing the same code more than once, and you run the risk of causing an error, takes up a lot of space, and all that. So this helps you make sure you understand what gets called, how many times things get called. Here's a nice example of a menu system where you have a function here which is just a bunch of print statements, so it can sit on a line by itself. All right, so it's a challenge activity. Let's see what this is. Type the program's output. So we define a variable called age to print, and we set that equal to 23. And then we call this print age function, which takes that value age to print as a sends it as an argument. And here we're just going to say he is, and then whatever that is coming in. So this is the print statement. And so what's going to be printed is 23 is here, 23 goes in there, 23 comes in here, and that's 23. So it's going to print out E is 23, and we enter because it's a print statement there. Let's see. All right, very good. The next one would be here we have two values, and we add them together, and then that is the single argument. The sum of these two values is going to be this. In this case, it's 24. So what ends up being the argument is 24. So what comes in here is 24. And so it's going to print out price colon $24. Okay. So that's how that one is. This one, we have, again, we have two arguments, two parameters, and what's going to happen is it's going to print out whatever the number 1 is minus whatever the number 2 is equals, and then inside here, first it's going to calculate whatever that is, and these are two integers, and then it's going to print out whatever that value is. So this actually is going to print out number 1, whatever the difference is, number 1 minus number 2. So if number 1 is 4 and number 2 is 1, it's going to print out 4 minus 1, okay, equals whatever 4 minus 1 is, which is 3, right? Okay, and then it's going to print that. Is that right? Oh, that's good. Okay. All right, here it's just a name and an age. Prints out a name and an age, and then it's gonna do username 2 and age 2. So first it's gonna do this one and this one, and next time it's gonna do this one and this one. So it's gonna print out twice. It's gonna say Ann, comma 24, and then it's gonna print out Bob, comma 19. Okay, so that's that one. And here again, we do a calculation first, and then the sum, the result of the calculation gets passed as the argument. So it's still 3 arguments. 1, 2, 3. That's the third argument. Comes in as 1, 2, 3. So here it prints the name, here it prints 1, here it prints 2, here it prints 1, here it prints 3. See? So that's how that works. All right, what's this one? Print functions. We have location minus population, location dash population pairs are read from input and passed as arguments to this function. And we're supposed to define it, which has 2 parameters and outputs on 1 line. So all in 1 line, prints out the value of the first parameter, has the value of the second parameter, people. So it looks something like this. The name of the function is def print city size, and it's got 2 parameters, city and size, I guess, number of people, I guess, size, num peeps. How's that? Oh, cute. And so I'm going to print out print. I'm going to do this F thing. First parameter, city, has num peeps. People. Looks like it's with the period. End quote, end parentheses. All right, so let's just see if this is right. Yes, that's right. So you see it doesn't return any value. So since it doesn't return any value, just put it out there on a line all by itself, and it does what it does. And what it does is it prints something out. All right, so the next one is you're going to print out, you're going to read in a name and a salary and a name and a salary. So you don't have to store anything. You just have to it's just going to, you read in these four things, and then you print out that and that. So it's just going to be something like, print, def this, copy this, and it's going to be and name and salary, and you're just going to do print F single quote dash dash space dash dash space curly brace name dash dash and then I guess we have to do a new line. That's what I'm doing. I'm going to do it a different way just to show you we can do it different ways. And then I'm going to say print F dash earns an integer number, which is S, dollars per year, period. Okay. So let's see if that works. Oh, did it work? Yeah, I guess it worked. Okay, very good. Okay. What would this one be? You're gonna read in four things. Print the difference of two. There's two parameters. Followed by the result of subtracting the first parameter from the second parameter. Okay, so it's going to read in two parameters, and it's going to print out the difference between the two parameters, which is minus 19 minus 6 is minus 13, I guess. Must be. And then 14 minus 23 is minus 23 is same as 14 plus 23, which is 37. Oh, minus 19 minus 6 is the same as minus 19 plus 6, which makes it minus 13. Okay, so it's pretty easy. You just do the function is going to be named this. Tell you what, I'm just going to do this. Copy. I'm going to do lazy. I'm just going to use these two same names. They can be the same names, doesn't matter. And the result, I'm going to call it res, equals num a minus num b and then I'm going to return res. No, I'm not supposed to return res. I'm supposed to do print f result colon space curly res. Done. Okay, that's all I gotta do. What did I do? Oh, I forgot to say def. You probably saw that. You're probably watching this video saying, def. All right, that one works. And so kind of the dumb point here is that, it doesn't matter what they're called up here. They can be the same, they can be different, whatever. It's just got to be consistent inside here. That's all. All right, the last one is read info. Oh, you're supposed to, okay, so you're supposed to type in two names. Okay, you read in two names, and then you read in two ages. And you say the first name is that year's age, and the second name is that year's age. So, you just do N1 equals input, N2 equals input, A1 equals int input, A2 equals int input, print details up N1 A1, print details N2 A2. If this is right. All right, very good. Okay, anyway, so that is print functions. Is that it? Okay, good. Dynamic typing. Okay, so what dynamic typing is about is that the type of a variable is more has to do with the context of the variable. Okay, like for example, and normally it might not be an issue, but in the case of a plus sign, if the two variables are strings, then the plus sign will concatenate. This one, it'll take the x, and after the x, it'll concatenate onto the y. But if these two variables are numbers, then it's going to be addition. So it'll add the two numbers. And that's polymorphic functions. It's dynamic typing. And also the types can change, and they do. See here, the first time you read this, these x and y are integers. They're integers because they come in as integers, or maybe they can be floating point 2 or whatever. But then the second time add is called, these are strings. The arguments are strings. So these are going to come in and they're going to be strings because they come in as strings because they're sent in as strings. So that's dynamic. That means that it can change. It can change while the program is running. Okay, and that's different than other more restrictive languages like C, C++, Java, other languages that you've heard of, and where once you declare the type of the variable, if you use it as an integer first time, that's it. It's an integer. Okay, you can't just change it next time. In fact, when you have this is an assignment statement in either Java or C# or whatever, and so this is saying that you have a variable called name, and that variable name is equal to this string, JOHN. This is the declaration. It declares name as a string. So we say the string variable call name equals this string. So that's static typing. So you actually have to say. All right, there's no challenges in here. That's just something to know. Okay, so here we have reasons for defining functions, and they're just what you'd think. It improves readability, makes programs easier to understand. Steps to feet, steps to feet, so on. Steps to calories, or steps to calories. In this example, okay, I don't see. Okay, never mind. We'll get to that. Okay, so that's one, mods for development. You avoid writing redundant code. Here, you're trying to figure out the area of a pizza, about 3 pizzas or whatever, and here you have it 3 times and so on. You don't need to do it that way. You can just have one, calculate the circle area of a pizza, and so here we're using it twice. See, here, instead of coding it twice, copy paste kind of thing, we just define a function and we use that with the parameter. The parameter is what's different each time. All right, so go through that. Here is a you write a function so that the main program below can be replaced with by simpler code that calls this function, miles per hour and minutes to miles. Oh, miles per hour and minutes to miles. So it's going to return miles, and so it's going to input. So the function is going to be this: copy def this, and it's going to take in a MPH and a M. I'm going to say a minutes and miles per hour. Okay, that's okay. I'm going to call it M for minutes, because anyway, miles per hour in minutes. And so we're returning. We are returning miles equals function. The original main program is this, so I'm going to copy this here. Copy. I'm going to put that here. I'm going to put it here. Tab, paste. This is going to be messed up. Okay, I'm just seeing if there's I'm seeing if this is an easy way to do it. Okay, we already have that, and we already have that. That's this, and that's this. And then that, after that is done, we put the miles per hour is the first parameter, and minutes is the second parameter. Okay, so I'm going to say miles per hour, copy, paste, and minutes traveled, copy, paste. Okay, so it's this, and so I don't need to have these two statements because they come in as parameters. And so we have this is the same as that, and this is the same, and this calculates the hours traveled, and miles per hour is this thing. So I think now we're returning miles, so we can return miles traveled. Okay. See if this is right. All right, very good. All right, let's see where we are. We've done We've done that. All right. I think I'm gonna. This is up to. So we've done up to 3 point. Or we've done up to 9.4. We finished 9.4. That's what we just finished. The next one is writing mathematical functions. What is important here? I think this writing mathematical functions has mostly to do with, there's usually involves a bunch of numerical parameters and it returns a numerical result. So it's a function, it has a return, and it has parameters, and everything's numerical. Okay, so here's an example of one that converts height in feet. You enter the height in feet and then in inches. That's 2 parameters, and the result is centimeters. So this is what you return. So this is an example of that. It talks about these functions. This is temperature conversion, centigrade to Fahrenheit kind of thing. You can see that a lot. This is an example of calling functions in expressions. So here we have an expression, and it's to compute this C2 value, and this is a function, and this is the same function, but with different arguments. So this is going to be executed twice, one for the first one and one for the second one, each time with a different parameter. And then so we have a single value here, and that's what we print out here. Anyway, that's not that big of a deal. All right. Okay, let's do this. Okay, assign max sum with the greater of this or this, plus the greater of this or this. Okay, so we're gonna use one statement. Okay, so we have a function here that will return the maximum value. It takes in 2 parameters, figures out what the biggest one is, and that's the one it gives you back. Okay, that's all. And so what we're supposed to do is blah, 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 blah. So we're supposed to say we're computing this thing. So max sum, we're supposed to do it on one line. Max sum equals the max of A and B. Wait a minute. Max of num A and num B. So it equals the max. Find max. It's this thing. Find max. Do this. Copy. Like that. Right here. But not. Okay. Plus the same thing. Okay. So we're calling find max twice. But it's not what it's going to be. The first one, it's going to be num A and num B. And the second time, it's going to be num Y and num Z. Okay? Num A, num B, maximum is 10. Num Y, num Z, maximum is 7. So 10 plus 7 equals 17. Okay. Yeah, all right. Does it work? Yeah, it does. Okay, fantastic. Modular functions from mathematical expressions. Modularity allows for more complex functions to incorporate simpler functions. Complex mathematical functions often call other mathematical functions. Blah, blah, blah. Okay, so let's just see what this is, and then we're done. Okay. Complete the function liters to pints that has one parameter as a volume in liters. The function returns the volume converted to pints, given that 1 liter equals that many pints. So if the input is 6, the output's going to be that many pints. This number of liters equals that many pints. Oh, we have the conversion number here. Okay, great. We're going to use that. Have we talked about global variables yet? I don't know. Let's see it here. Okay, well, let's see what happens. Our code, my code goes here, so I'm going to say I'm going to return. I think I can do it all in one line. Liters times liters to pints, I guess. Copy, paste. Okay, so I think that's what it is, but see, I don't know if this, I don't know how we do global variables in Python, but we'll see if this works. We'll see if this is correct. We'll see if this, we'll see if this is visible inside the function. That's what I'm wondering. And if I don't have to say anything. In other languages, I'd have to say that, oh, this is a global variable, and so you're not going to see the definition inside here. Look outside, or not. So anyway, let's see what let's see if this is right. Wow, it's right. So and we will get into my comment I just made. That has to do with the scope of variables, and we're going to get into that later, I think. But anyway, so why don't you go ahead and do the rest of these. Convert liters to ounces. No, convert to liters. Oh, cups and ounces. Okay, right, because so it's something like def this, and it's going to be something like first it's convert to liters. So I'm going to say liters equals user cups times fluid times this. Plus this. Okay, so this is how many ounces, and then we're going to convert. We're using this constant, use liters to per fluid ounce. So it's this quantity. I'm going to use parentheses to make sure that first that's calculated. Then I'm going to multiply that by this number, liters per fluid ounce. Okay, and that's what I'm going to return. Okay, I'm going to see if this is right. Oh, where did I get wrong? Takes one positional argument, but two are given. Oh, it just takes. Oh, what happened? I gotta put this. Oh, I bet I did a cut instead of a copy. All right. Yeah. Weird. Okay, let's check this one. All right, that one works. Okay, so the last one is define two functions. This one and this one, it looks like. First we read in this, and then we print out Side length, base area, surface area. Side length, base area, surface area. So we're going to write functions for def this, copy paste, and which is going to be this area. I'm just going to do return straight to the punch. Return user side. This, copy this times this. Okay. User side length squared. User side length times user side length. So that's what that is. And then we also have to do def this thing. Copy, paste. I'm going to put a little space there. And that's a colon. And I'm going to return user side length times base surface area. Go ahead. So return find base area of user side length. So that's going to be the surface area, and then their base area times 6. Weird. So that's what I think the answer is. Let's see if it's right. So here I'm using a function inside of a function, and that is correct. All right, so function stubs. Let's see where we are. I have to leave in 10 minutes. So stubs, branches and loops, objects. Okay, great. So we ended with writing mathematical functions. Okay, I think I'm gonna end this video here, and I will I'll make another video starting with function stubs 9.6. Okay, hope this helps. Thanks for watching.